Beneath a sky scattered with stars, a child looks upward. The night stretches outward like an endless ocean of light, yet something stirs in the silence, a quiet truth that what the eyes see is only a fragment of what is real. Humanity has always trusted its senses, binding its understanding of existence to the three dimensions of space and the steady current of time. Forward and back. Left and right. Up and down. A fourth line, the ticking arrow of time, drifting endlessly forward. Together, they form the prison of perception, the narrow corridor through which reality appears. But the universe is not obliged to reveal its full architecture to those who dwell within it. Physics whispers of hidden corridors, dimensions folded beyond sight, invisible to both eye and instrument, like a vast cathedral whose walls we can never step beyond. If such hidden dimensions exist, then everything known, the movement of galaxies, the burning of stars, even the birth of time itself, may be but a faint shadow projected from deeper realms. A higher structure, immense and unseen, could cradle this universe the way a canvas holds a painting. The thought is as terrifying as it is beautiful. It suggests that what we call reality is incomplete, a surface world, thin as a veil, stretched over a deeper geometry. Science has begun to suspect it. Equations hint at missing pieces. Gravity behaves like a force leaking into places unseen. And the mathematics of string theory demands more than 4 dimensions, whispering that the universe we know is only a surface upon which deeper realities are written. The mystery stands before us, silent and immense. Does reality conceal hidden dimensions curled beyond the edges of perception? At the dawn of the 20th century, the universe itself was being rewritten. Newton's cosmos, orderly, absolute, and ruled by invisible forces acting at a distance, was giving way to a deeper vision, born in the mind of a quiet thinker from Bern. Albert Einstein's general theory of relativity, unveiled in 1915, shattered the old scaffolding of the heavens. In his vision, space and time were no longer empty backdrops upon which the drama of matter unfolded. They were woven together, a single dynamic fabric that bent, curved, and stretched in response to mass and energy. Gravity was not a pull across space, it was space itself, reshaped by presence. This revelation was profound. The orbit of planets, the fall of an apple, even the light of distant stars, all were guided not by a hidden tug, but by the bending of spacetime itself. Reality was geometry. And in this geometry, Einstein gave humanity its first glimpse of a universe stranger than common sense could contain. Yet, even as the theory explained so much, a question lingered in the shadows: could this elegant fabric be only the beginning? Could spacetime itself conceal layers deeper still? In 1921, a German mathematician named Theodor Kaluza took a daring step. He proposed that Einstein's equations, which described the warping of 4-dimensional spacetime, could be extended into a 5th dimension. Not merely as an abstract trick, but as a hidden reality. Within this extra dimension, Kaluza found something astonishing. When the mathematics was carefully unfolded, the equations of electromagnetism, the laws governing light, charge, and magnetic fields, emerged naturally alongside Einstein's description of gravity. Two of nature's fundamental forces, long considered distinct, appeared to be united within a higher dimensional geometry. It was a breathtaking possibility that the universe might be constructed not from separate, isolated laws, but from the curvature of an unseen dimension beyond human perception. Gravity and light, woven together by a geometry deeper than 4-dimensional spacetime. 5 years later, in 1926, the Swedish physicist Oscar Klein extended Kaluza's vision further. Klein suggested that this 5th dimension might be hidden from ordinary experience because it was compactified, rolled up into a tiny circle, smaller than an atom, smaller than anything the eye or instrument could perceive. Like a thread that, from a distance, appears one-dimensional, but upon closer inspection reveals a circular depth. In this picture, spacetime was not the smooth, flat sheet imagined by daily perception, but a vast tapestry with each point curled into invisible loops. The universe, it seemed, could be hiding corridors of motion too small for human senses to follow. It was a daring hypothesis, balancing on the edge between physics and philosophy. For many it was too radical. The mathematics was compelling, but without experimental evidence, it remained a dreamscape of theory, easily dismissed as elegant speculation. The early decades of the 20th century were already brimming with upheaval. Quantum mechanics had arrived, revealing a world of uncertainty and probability beneath the surface of matter. Electrons flickered between states. Light behaved as both wave and particle. And the deeper physicists peered, the stranger the foundations of reality became. In this storm of discovery, the idea of hidden dimensions seemed too fragile, too speculative to withstand the scrutiny of experimental science. The mainstream of physics turned elsewhere, toward the strange dance of quantum particles, toward the structure of the atom, toward the forces that bound protons and neutrons within the heart of matter. For decades, the notion of hidden dimensions lay dormant, a whisper at the margins of science, too beautiful to be forgotten, yet too elusive to be proven. But theories do not die easily when they solve problems that otherwise remain unsolved. As the 20th century advanced, physics encountered a rift at the heart of its structure. On one side stood Einstein's relativity, a majestic theory of spacetime, smooth and continuous, governing the large-scale motions of stars and galaxies. On the other stood quantum mechanics, precise and astonishingly successful, describing the jittering chaos of particles in the microscopic realm. Each was a triumph. Yet they could not be reconciled. The mathematics of one refused to merge with the other. The universe seemed to operate under two separate languages, the grand geometry of the cosmos, and the restless probability of the quantum world. Into this fracture, the old whispers of hidden dimensions returned. By the mid to late 20th century, physicists began exploring new frameworks that could unify the forces of nature into a single story. Out of these efforts arose string theory, an audacious vision suggesting that the fundamental building blocks of reality are not point-like particles, but tiny vibrating strings of energy. These strings, according to the mathematics, could only exist consistently within a universe of 10 dimensions. Not 4. Not 5. 10. And later, in refinements of the theory, even 11. Here, the echoes of Kaluza and Klein rang out once more. The compactified dimensions they once imagined became essential to the mathematics of string theory. Each string's vibration depended not only on the 3 dimensions of space visible to the human eye, but on hidden dimensions curled tightly upon themselves, shaping the energy and character of every particle in existence. Electrons, quarks, photons, all might be nothing more than different resonances of strings vibrating within higher dimensional geometry. Still, skepticism remained. These ideas, though mathematically elegant, demanded evidence, and evidence was scarce. The scales at which hidden dimensions might reveal themselves were unimaginably small, far beyond the reach of early experimental tools. Yet science pressed forward. From accelerators probing deeper into matter's core, to satellites mapping the faint afterglow of the Big Bang, the search for signs of hidden dimensions became one of the great pursuits of modern physics. The story of hidden dimensions is thus not a sudden revelation, but a slow unfolding. It began with Einstein's elegant geometry of spacetime, expanded by Kaluza's bold leap into a 5th dimension, refined by Klein's vision of compactified space, and carried forward by generations of physicists striving to unify the discordant forces of nature. Through it all, one question has remained suspended in the air, vast and unresolved: is the universe truly 4-dimensional, or are our senses blind to a deeper structure hidden beneath the surface of reality? In this tension lies both the beauty and the terror of modern physics, that every familiar law, every certainty of existence, may rest upon unseen dimensions we have yet to touch. The human mind is a prisoner of its own evolution. It was shaped not for the infinity of mathematics nor the hidden architecture of the cosmos, but for survival, walking planes, throwing stones, measuring distances in horizons and heartbeats. 3 dimensions of space were enough for the hunt, enough to build fire, enough to carve civilization from the dust. Forward and backward, left and right, up and down. These became the boundaries of thought, the compass of existence, and time, an arrow moving relentlessly forward, was accepted as the silent current carrying all things to their end. Yet if reality is built from deeper geometries, then the mind that navigates within 3 dimensions is blind by design. Like a 2-dimensional creature sliding along a flat surface, unable to imagine the depth rising above its plane, humanity peers into the cosmos without knowing how many layers stand hidden beyond its sight. To imagine a 4th spatial dimension is to stretch the mind until it nearly fractures. One can picture shadows, lines drawn by higher forms upon lower surfaces. A cube casts a square. A tesseract, a 4-dimensional cube, casts a strange and shifting shadow into 3-dimensional space. But these are only faint echoes, incomplete reflections of something the human eye was never built to behold. This is why the idea of hidden dimensions feels so unnatural, so destabilizing. It forces reality to step outside the architecture of human intuition, into a territory where imagination struggles and language falters. The first scientific tremors of this revelation appeared not in astronomy, but in the invisible force that lights the world. James Clerk Maxwell, in the 19th century, had written his famous equations of electromagnetism, a system of laws that described how electric and magnetic fields ripple and weave together, forming the foundation of light itself. These equations worked with precision so uncanny that even today they remain untouched, among the most perfect descriptions in physics. Yet when Theodore Kaluza extended Einstein's equations into a 5th dimension, something remarkable occurred. Maxwell's equations emerged naturally, as if they were already hidden within the higher dimensional geometry. In other words, electromagnetism, the force that powers every star, guides every photon, charges every circuit, was not a separate law at all. It was geometry. A byproduct of bending not 4 dimensions but 5. The shock was profound. For centuries, forces were seen as irreducible aspects of reality, mysterious in origin, simply existing as givens of the universe. But here was a clue that forces might not be fundamental at all. They might be the shadows of higher dimensional shapes, projected down into the world of human experience. And then came the unsettling question of gravity. Gravity has always been the strangest of forces. Compared to the electromagnetic force that binds atoms together, gravity is incomprehensibly weak. A simple magnet can lift a paperclip against the pull of the entire Earth. The strong nuclear force that binds protons and neutrons inside the atom is stronger still. Why is gravity so feeble, so diluted, when it sculpts galaxies and bends light across billions of years? The mathematics of higher dimensions offered a haunting possibility. Perhaps gravity is not weak at all. Perhaps it only appears weak because it does not belong entirely to the visible universe. Like water spilling through cracks into deeper layers, gravity might be leaking into hidden dimensions. What humans feel as the faint tug of weight, an orbit may only be the residue of a force stretched thin across realms unseen. If true, then every falling stone, every circling moon, every collapsing star is not merely following the curves of familiar spacetime, but is whispering across the boundaries of a greater reality. The emotional weight of this realization cannot be overstated, for it suggests that the most universal of experiences, falling, standing, carrying mass, is not fully contained in the world humans inhabit. That beneath the surface of what seems ordinary lies an incompleteness, a gap in perception so vast it swallows the very foundation of physical law. Reality, then, may not be the solid ground it appears to be. It may be only a fragile surface stretched across a deeper framework, like the skin of a drum vibrating with unseen depth beneath it. The strangeness deepens further when one recalls how evolution anchors the mind. Consider the creature of 2 dimensions again, an intelligence existing only on a flat sheet, unable to step outside its plane. To such a being, the concept of above would be inconceivable. And yet, from a higher perspective, its entire world could be lifted, bent, or folded without its knowledge. So too with human perception. What feels complete, 3 dimensions of space, 1 of time, may in truth be only a shadowed slice of something vaster, unseen not because it does not exist, but because the brain was never shaped to perceive it. The shock lies not merely in the mathematics, but in the philosophical rupture it forces, that what humans call reality may not be reality at all, but only the visible portion of a deeper geometry. In the 20th century, physicists began to probe this idea with greater intensity. Some suggested that the hidden dimensions might be curled so tightly that even the smallest particles cannot detect them. Others speculated that vast extra dimensions might exist just beyond perception, invisible but real, exerting subtle effects on the universe. Theoretical frameworks like string theory took these whispers seriously, building entire models of the cosmos where 10 or 11 dimensions were not optional curiosities but absolute necessities. Without them, mathematics collapsed. It was a radical inversion of perspective. Instead of extra dimensions being speculative flourishes, they became the stage upon which all known physics might rest. The consequences ripple outward like shockwaves. If dimensions exist beyond the visible four, then the structure of matter, the birth of stars, the origin of the cosmos, all are not confined to the surface humans inhabit, but are shaped by the geometry of hidden realms. Dark matter, elusive and invisible, may be nothing more than matter existing partly within these unseen dimensions, its gravity bleeding into the universe while its substance remains forever hidden. Even the fate of the universe itself may depend on them. If space-time is but a membrane, floating in a higher dimensional bulk, then the end of this universe may not be an end at all, but a transformation within a larger framework of existence. The scientific shock of hidden dimensions is not merely intellectual. It is existential. It forces humanity to confront the possibility that the cosmos is far larger, far stranger, than what eyes can see or what minds can easily imagine. That reality, as it appears, is not the full story but only a page torn from a book too vast for comprehension. And if this is true, then the human species, its history, its future, its every thought, exists not in the full theater of reality, but upon the fragile surface of a deeper, hidden stage. The whispers of hidden dimensions were once the province of mathematics alone, suspended in equations, beautiful but untouchable. Yet as the 20th century gave way to the 21st, the tools of science grew sharper, reaching into realms where speculation might become testable truth. Physicists turned their gaze in two directions at once, downward, into the smallest scales of matter, and outward, into the vastest reaches of the cosmos. For it was here, at the edges of human measurement, that signs of hidden dimensions might leave their faintest fingerprint. Deep beneath the fields of Switzerland and France, a colossal machine hums in the darkness. The Large Hadron Collider, operated by CERN, is the most powerful particle accelerator ever built. Within its 27-kilometer ring, protons are hurled at nearly the speed of light before smashing together in bursts of energy that recreate conditions not seen since the dawn of the universe. The goal is simple yet profound: to break matter into its smallest pieces, to see what emerges from the fragment. And among the many questions this machine was built to explore lies one of the boldest: whether collisions at unimaginable energies might reveal the presence of extra dimensions. The logic is as strange as it is compelling. If hidden dimensions exist, particles accelerated to extreme energies might vanish into them, carrying energy away from the collision. In the detectors, such events would appear as sudden absences, missing energy where none should be missing. A particle, born in this world, would seem to dissolve into an unseen corridor. Some physicists even speculate that miniature black holes might form within the collider, not dangerous to Earth but revealing of higher dimensional space. For in certain models, such black holes evaporate in patterns that betray the geometry of the dimensions through which they collapse. Thus far, no definitive signs have been found. Yet the search continues, with every upgrade of the collider extending the frontier. In the silence of those subterranean tunnels, humankind listens for the faint echoes of a geometry beyond its own. While machines probe the microscopic, the universe itself offers another kind of evidence. In the vastness of space, a faint glow permeates every direction, a relic from the birth of the cosmos. This is the cosmic microwave background, the afterglow of the Big Bang, cooled over billions of years into a whisper of microwaves. It is the oldest light humanity can see, carrying with it the story of the infant universe. And written in its faint irregularities may be the signatures of hidden dimensions. If dimensions beyond the familiar four influenced the earliest moments of cosmic expansion, they could have left distortions in this primordial light, subtle anomalies in the temperature patterns that satellites like WMAP and Planck have mapped with exquisite precision. Some theories suggest that the geometry of compactified dimensions might ripple outward into the distribution of galaxies, or into the very shape of cosmic inflation itself. So far, the data is tantalizing but not conclusive. The background light reveals a cosmos governed by strange forces, dark matter, dark energy, whose origins remain unknown. Whether these are signs of unseen dimensions or of physics yet undiscovered is a question that remains suspended in silence. In 2015, humanity heard the universe for the first time. Across the detectors of LIGO, a faint tremor passed, a ripple in space-time itself, born from the collision of two black holes over 1 billion light-years away. Gravitational waves are distortions in the fabric of the cosmos, stretching and compressing reality as they travel. For Einstein, they were a consequence of relativity. For modern physicists, they are also a possible key to hidden dimensions. If gravity seeps into higher dimensions, then the waves it generates could carry subtle deviations, distortions in their frequency or strength, that betray the presence of unseen realms. Future detectors, such as LISA, a planned space-based observatory, may be sensitive enough to test these ideas. By listening to the universe with greater precision, scientists hope to hear whether its deepest vibrations echo through dimensions beyond the visible. Each ripple is not merely a wave of gravity, but a messenger, carrying with it the possibility that space-time itself is incomplete. While experiments strain the edges of technology, mathematics whispers insistently. In the frameworks of string theory, the idea of extra dimensions is not a choice. It is a requirement. The theory describes the fundamental particles of nature not as points, but as tiny vibrating strings, each mode of vibration corresponding to a different particle. Yet the equations only remain consistent in a universe with 10 or 11 dimensions. Remove the hidden layers, and the mathematics collapses. These extra dimensions are imagined to be compactified into intricate shapes, Calabi-Yau manifolds, curled beyond sight at scales far smaller than atoms. The geometry of these hidden spaces, according to the theory, determines the properties of the strings themselves, and thus the particles, forces, and laws of physics observed in the visible universe. In this vision, the richness of reality, its electrons, its quarks, its photons, is but the music of strings resonating within unseen dimensions. To physicists, this is at once exhilarating and unsettling. It suggests that the laws of nature are not inevitable, but the consequence of a geometry too small to see, yet vast enough to shape all existence. The further science peers, whether into the smallest collisions of particles, or the oldest light of the cosmos, the more incomplete the four-dimensional view of reality appears. The weak pull of gravity, the mystery of dark matter, the acceleration of cosmic expansion, the elegant but fragile balance of the fundamental forces. Each anomaly hints at something missing, some unseen structure underpinning the visible. It is as if humanity stands before a vast tapestry, gazing only at its front surface, while the knots and threads that hold it together remain concealed on the other side. The investigation is not finished. It has scarcely begun. Yet with every observation, every equation, every particle collision, the possibility grows stronger that what is seen is only the skin of reality, stretched across dimensions deeper than imagination allows. The pursuit of hidden dimensions is more than science. It is an act of humility. It forces humanity to confront the limits of perception, to accept that what feels complete may be only a fraction of the truth. And it reminds us that even the most advanced instruments, the colliders, the satellites, the detectors, are but lanterns carried into a vast darkness. What lies beyond the veil may yet remain hidden for centuries. But the search itself is a testament to the restless spirit of discovery, the refusal to accept that what is visible is all there is. For in the silence between particles, in the faint glow of the first light, in the trembling of space-time itself, the universe may be whispering of other dimensions, waiting for the moment when humanity can finally hear. Gravity is the most familiar of forces. It holds oceans to the earth, steers the planets in their endless arcs, and binds stars into galaxies. Yet, among the four known forces of nature, it is also the weakest. The electromagnetic pull of a simple fridge magnet can overcome the gravity of an entire planet. This strangeness is not a small curiosity. It is a profound imbalance in the architecture of reality, a flaw so deep that physicists have come to suspect it is a whisper from hidden realms. For centuries, gravity was seen as the glue of the cosmos, absolute and sovereign. Newton measured it. Einstein bent it into the curvature of space-time. And yet, even in Einstein's grand design, the force remains feeble, unimaginably weaker than the forces that govern atoms. Why? Some physicists believe gravity is not truly weak at all. Instead, it may be diluted, leaking like a subtle mist into dimensions we cannot see. Just as sound disappears when it escapes into the open air, gravity may be vanishing into higher layers of reality. This is where black holes emerge as silent suspects. A black hole is more than collapsed matter. It is a rift, a scar in the very weave of space-time. At its heart, all familiar physics breaks down, replaced by a singularity where density climbs toward infinity. But to some, these cosmic abysses are more than dead ends. They may be windows. In certain theories, black holes could act as portals into higher dimensions, funneling matter and information into realms beyond the boundaries of our universe. To us, the horizon is final, an event beyond which no signal returns. Yet from a higher dimensional perspective, what falls in may not be lost at all, but simply displaced into a direction our senses cannot follow. This idea flows naturally from a bold framework known as brain cosmology. Imagine our universe not as the entirety of existence, but as a vast sheet, a three-dimensional membrane, or brain, floating in a higher dimensional ocean, often called the bulk. Everything we know, from galaxies to atoms, is confined to this brain. Particles of light, the quarks of matter, the forces that govern them, all are trapped within its surface. Only gravity, mysterious and elusive, is free to roam beyond. This could explain its weakness. For while electromagnetism and nuclear forces are bound tightly to the brain, gravity disperses into the greater volume of higher dimensions, like a lantern casting its glow into an endless night. If this picture is true, then the cosmos we see is but a thin slice of a far grander stage. Our universe becomes a fragile film suspended in a deeper, hidden architecture, one we cannot touch, but whose presence is betrayed in the weakness of gravity itself. And in that hidden bulk, other brains may drift, entire universes, with their own stars, their own laws, their own stories of time and matter. Separate, parallel, and yet close enough that sometimes, just sometimes, their presence might touch our own. Some theorists propose that the greatest event in cosmic history, the Big Bang, may have been born not from a singular explosion within our brain, but from the violent collision of two such universes. Picture it, vast membranes, stretched across an unseen dimensional sea, colliding like waves upon an endless shore. The impact would have released unimaginable energy, igniting matter and radiation, giving birth to space and time as we know them. The fire of creation, not as an isolated miracle, but as the echo of a deeper, multidimensional dance. If this is true, then the beginning of our cosmos was not a unique spark, but part of a cycle, collisions, separations, and reunions, weaving countless universes into being across the hidden expanse. The weakness of gravity, the whispers of black holes, the scars of cosmic microwave radiation, all may be clues to this deeper story. And yet, with every step towards such revelations, reality grows stranger. The familiar world of stars and galaxies becomes a thin surface adrift in a higher reality we cannot see. Black holes, once feared as cosmic graveyards, become doorways to elsewhere. The weakness of gravity becomes not a defect, but a clue, a thread pulling us toward the possibility that our universe is not alone, but one of many, suspended like fragile lanterns in a vast and silent sea. There is both awe and unease in this vision. For it suggests that our cosmos is not sovereign, but contingent, a shadow cast by deeper geometries, a passing ripple in dimensions beyond comprehension. And yet, this is the hallmark of science, that with every layer peeled back, the world does not grow smaller, but infinitely larger, infinitely stranger. Each answer is a key that unlocks not certainty, but greater mystery. In the whispers of gravity, in the silence of black holes, in the possibility of colliding brains, the story of the universe deepens. A universe that once seemed vast and eternal may be only the surface of something far more alien than human imagination has yet dared to believe. In the search for truth, there comes a moment when observation alone is no longer enough. Beyond the reach of telescopes, beyond the precision of particle accelerators, lies a landscape that can only be charted by mathematics and imagination. It is here, in this realm of equations and thought experiments, that some of the most daring theories of physics have taken shape. They are bold, sometimes bewildering, and often unprovable. But they offer a vision of the cosmos where the familiar dissolves, and hidden dimensions may bind together the mysteries of reality. At the foundation of modern physics stand two mighty pillars, quantum mechanics and general relativity. Yet, like two great empires sharing a border, they are forever in conflict. Quantum theory governs the small, the jittering lives of subatomic particles. Relativity commands the vast, the fabric of spacetime itself. For decades, physicists have searched for a bridge between these worlds, a single framework that unites them. String theory emerged as that bridge. It dares to replace the familiar idea of particles as point-like dots with something far stranger, vibrating strings of energy. Each vibration, like a musical note on a violin string, gives rise to a different particle, electrons, quarks, photons, all the symphony of matter and forces. In this view, the universe is not made of particles, but of melodies. A cosmic orchestra playing in dimensions our senses cannot perceive. But there was a catch. The equations demanded more than the 3 dimensions of space and the one of time. To remain consistent, the theory required 6 extra spatial dimensions, curled tightly beyond our view, like invisible threads woven into reality's fabric. Thus, superstring theory was born, suggesting a universe of 10 dimensions, where the deepest truths of physics unfold in geometries far richer than human intuition. As elegant as string theory appeared, it was incomplete. Different versions arose, each with their own mathematics, their own predictions. And yet, like pieces of a puzzle scattered across a table, they hinted at something larger. In the mid-1990s, Edward Witten and others proposed a unifying framework, M-theory. This theory suggested that all 5 variants of string theory were not rivals, but reflections of the same deeper reality. In M-theory, strings were not the only players. Higher-dimensional objects, membranes, or brains, emerged, stretching across vast dimensions beyond the familiar 4. And suddenly, a new possibility appeared, an 11th dimension. In this vision, our universe could itself be a 3-dimensional brain floating within a higher-dimensional space, like a bubble drifting in an unseen ocean. Other bubbles might drift nearby, entire universes, each with their own laws of physics. And between them, hidden forces could ripple, sometimes colliding, sometimes separating, shaping the birth and death of entire realities. If these extra dimensions exist, then the concept of a single universe begins to dissolve. The cosmos we observe may be only one region in a vast, layered reality, the multiverse. Some interpretations suggest that each universe is like a page in an infinite book, bound together by dimensions we cannot touch. Others propose that new universes are constantly budding from quantum fluctuations, like sparks flying from an eternal fire. The multiverse remains a deeply controversial idea, for it pushes the limits of science itself. By definition, other universes may forever remain inaccessible to observation. And yet, the mathematics of higher dimensions seems to whisper their existence, suggesting that our cosmos may be just one note in a grander harmony. The early universe, too, hints at hidden dimensions. Moments after the Big Bang, the cosmos expanded at a rate beyond comprehension, a process called inflation. It smoothed space, stretched quantum ripples into galaxies, and set the stage for everything we see today. Some theories suggest that inflation was driven by a false vacuum, a state of energy that seemed stable, but was not. Like a ball resting on a hilltop, it could roll into a deeper valley, releasing energy that drove expansion. Here, higher dimensions may have played a role, channeling forces from realms beyond our own into the newborn universe. And the possibility remains unsettling. If our universe rests in a false vacuum today, it could one day collapse into a lower energy state, rewriting the laws of physics in an instant. A transformation invisible until the moment it begins, silent, unstoppable, and final. Yet not all clues lie in the distant past. Even in the laboratory, strange phenomena hint at unseen connections. Quantum entanglement binds particles together in ways that defy classical understanding. When two particles are entangled, the state of one instantly influences the other, no matter the distance between them. Einstein called it spooky action at a distance. But today it is a proven feature of quantum mechanics. Some speculate that this hidden connectivity could be evidence of dimensions beyond our sight. That entangled particles may not be communicating through space, but instead through shortcuts in higher dimensions, like 2 points touching in a folded sheet of paper, though they seem far apart when flattened. If so, then entanglement may be more than a quantum curiosity. It may be a glimpse into the invisible scaffolding of reality, where dimensions beyond the fourth quietly weave the universe together. Each of these theories remains unproven. Strings have not been detected. Extra dimensions have not been measured. The multiverse, by its very nature, may lie forever beyond our reach. And yet, these ideas are not born of fantasy. They arise from mathematics tested against known laws of physics, from patterns that emerge when quantum mechanics and gravity are forced to speak the same language. They are speculative, yes, but they are also the best maps we have of a territory we cannot yet explore. In the end, these theories invite us to see the universe not as a finished picture, but as a mystery still unfolding. They suggest that what we call reality may be only the surface of something deeper, richer, and far stranger than we can imagine. Whether strings or brains, multiverses or hidden dimensions, these ideas do not close the story of science. They open it wider. They remind us that the greatest discoveries may not lie in what we see, but in what we cannot. And in that unseen realm, where mathematics becomes poetry and speculation brushes against truth, we glimpse the possibility that the universe is not just vast, but infinite in ways we have yet to dream. The search for hidden dimensions does not live only in thought experiments, or in the quiet halls of mathematics. It has left the chalkboard and entered the colossal machines of modern science, structures of steel and magnets, of mirrors and lasers, built as if humanity were trying to touch the edges of reality itself. Every instrument is a question given physical form. Every collision, every ripple of light, is an attempt to catch the whisper of a world beyond the visible. Beneath the rolling countryside near Geneva, an invisible ring is carved into the earth, 17 miles long, colder than deep space, and humming with power. This is the Large Hadron Collider, humanity's most ambitious particle accelerator. Here, protons are whipped close to the speed of light, and then allowed to crash together with such violence that they recreate conditions not seen since the birth of the universe. Within those tiny flashes of creation, physicists look for more than just particles. They look for fractures in the pattern of known physics, subtle deviations that might signal the presence of higher dimensions. Some theories suggest that in these collisions, energy could briefly concentrate into something extraordinary, miniature black holes. These tiny singularities would vanish almost instantly, evaporating in a spray of particles. But their very appearance would be an unambiguous fingerprint of hidden dimensions, because only in a universe with more than 3 spatial directions could such black holes form so easily. The collider has not yet revealed such shadows. But with each upgrade, each experiment, the hunt grows sharper. The machine is not simply smashing matter, it is smashing the walls of human intuition, pressing against the very geometry of existence. Far from the roar of colliders, another tool waits in the quiet of the cosmos. It is called LISA, the Laser Interferometer Space Antenna, a mission still in preparation but designed to listen to the universe with impossible delicacy. 3 spacecraft will form a triangle millions of kilometers wide, connected not by cables but by beams of laser light. Together, they will measure shifts smaller than the width of an atom, caused by the passing tremors of spacetime, gravitational waves. Most waves will come from colliding black holes or merging neutron stars, vast cataclysms echoing across the universe. But theorists whisper of stranger signatures, ripples that bend or fade in ways unexplained, hints that gravity is being tugged into dimensions beyond the 3 we know. If LISA detects such distortions, it would mean the cosmos itself is not fully contained within the surface we see. Gravity would become a messenger from another realm, carrying the weight of invisible spaces. Beyond colliders and space antennas, another frontier stretches in silence. The cosmic maps drawn by astronomers. They chart galaxies, clusters, and filaments, not only to understand what is visible, but to reveal the vast majority of the universe that remains hidden. Dark matter. Dark energy. Names that are less explanations than placeholders, tokens for mysteries that may run deeper than physics itself. Dark matter bends the paths of galaxies, holding them together as if gripped by invisible hands. Dark energy pushes the universe outward, accelerating its expansion in a silent rebellion against gravity. Could these unseen forces be the fingerprints of higher dimensions? Some theories suggest that what we call dark may not be dark at all, but simply the projection of deeper realities, leaking into the thin surface of our three-dimensional world. Like shadows on a wall, their presence is real, but their source lies elsewhere. Astronomers deploy surveys of unprecedented scale, mapping billions of galaxies across cosmic time. Every data point is a faint hope that somewhere, hidden in the mathematics of the sky, the trace of an extra dimension will emerge. Across colliders, telescopes, satellites, and detectors, one theme is constant: the relentless search. It is the human refusal to accept the surface of things. A refusal born from the suspicion that what appears solid and complete may be only a fragment, a skin stretched across something deeper. The ancients looked up and wondered if the heavens were infinite. Now humanity looks inward and asks if space itself hides unseen corridors. The scale of the tools has changed, but the essence of the question remains the same. Every collision at the LHC, every pulse of laser light in LISA, every map of dark matter spread across the night sky, each is a knock on the same locked door. And though the door has not yet opened, the act of knocking has reshaped human understanding. For whether or not hidden dimensions reveal themselves, the search is a mirror of human nature, an unwillingness to accept that reality is all that it seems. Perhaps the most haunting truth of all is that the answer may already be written into the universe. It is there, hidden in the geometry of space, in the tremble of gravitational waves, in the unlit scaffolding of galaxies. It is there, waiting for instruments delicate enough, questions sharp enough, and minds patient enough to recognize it. If dimensions beyond the known truly exist, then reality as perceived by human senses is incomplete. What appears as the universe may be only a thin slice of a grander whole, a surface layer of something vast and unreachable. The search continues not simply for knowledge, but for belonging, for the reassurance that humanity's place in the cosmos has not yet been fully measured. Because if hidden dimensions exist, then the story of the universe is not finished. It is not a closed book, but a page torn from a far greater volume. And somewhere, in the hum of colliders, the silence of lasers, or the pull of galaxies unseen, that greater volume waits to be opened. Beyond the veil of stars, past the fabric we call space and the rhythm we call time, there may lie structures we can neither see nor feel, dimensions folded so tightly that even light itself is blind to them. For centuries, humanity has looked upward, convinced that the universe stretched only as far as the eye could reach. Then came the revelation of galaxies, of expanding space, of unseen dark matter binding the cosmos together. Each discovery pushed the boundaries outward. And yet, if modern physics is correct, the greatest expansion may not be out there at all, but beneath the very surface of reality, hidden layers of existence, interwoven with our own, like pages in a book we have only just begun to open. String theory, with its trembling filaments of energy, whispers of 10 or 11 dimensions. Quantum theory, with its ghost-like probabilities, hints at deeper frameworks concealed beneath the measurable. Even the silent pull of gravity, so much weaker than the other forces, suggests leakage, as if its strength were diluted across unseen realms. These are not fantasies, but serious attempts by science to reconcile the paradoxes of the cosmos. If hidden dimensions exist, then everything we know is only the faintest surface. Life and death may not be edges, but ripples on a deeper ocean. Time itself, the arrow we so faithfully follow, may be just one thread in a much larger weave. And what we call the present could be a shadow cast by structures that lie far beyond the reach of human perception. In this light, discovery is always humility. Every new frontier reveals not mastery, but our smallness. To imagine higher dimensions is not to conquer them, but to admit that reality is vaster than thought, older than language, deeper than memory. Are we then creatures of the surface, forever confined to the visible layers of existence? Or are we standing at the threshold, preparing to open senses we do not yet possess? The history of science is filled with transformations of perception, sound beyond hearing, light beyond sight, particles smaller than imagination. Perhaps the blindness is only temporary. Perhaps the dimensions are waiting for us, as stars once waited for the telescope. This question does not belong to physicists alone. It touches the meaning of what it is to be human. If the universe is layered with hidden realities, then our lives are not simple lines drawn across time, but intersections in a tapestry whose full design remains unseen. To be born, to die, to love, to grieve, all may unfold in ways that escape our narrow vision. And the mystery does not diminish the meaning. It deepens it, for the unknown is not an absence, but a presence, a reminder that we are immersed in something infinitely larger than ourselves. As the last echoes of the day fade and the night sky reveals its silent fires, one truth lingers: what we see is only the surface glow. Behind the stars, behind the darkness itself, lies an architecture of reality still hidden, still waiting. Perhaps we will never pierce it. Perhaps we are destined to live as shadows on the skin of a vast, multidimensional cosmos. Or perhaps, someday, the barriers of perception will yield, and we will awaken into deeper rooms of existence. Until then, we look upward, and inward, with wonder. The sky above is not the end. It is only the first layer.